Hello everyone, let us see the next part of agrochemicals, that is part 3. Here in this part we will see the pyrethroids, the idea of pyrethroids. So what are these pyrethroids? Pyrethroids are natural as well as synthetic contact insecticide. Remember, these are natural as well as synthetic, but mainly they are contact insecticide. That means by mere contact of these compounds, they show the insecticidal properties. And about these pyrethroids, they are used from ancient time. From long ago, we are using this as natural pyrethroids or natural insecticides. So how these pyrethroids are isolated? See, this pyrethrum powder, generally it is available in the form of powder. It is obtained by crushing dried flower heads of Chrysanthemum cinerariofolium. So this is commonly known as Dalmatian insect flower, and in Marathi it is known as Sevanti. The flower of Sevanti is is the botanical name of this plant is Chrysanthemum cinerariofolium, commonly known as Dalmatian insect flower. The flower heads of this plant are dried. This powder is formed by dried flower heads, and these dried flower heads are the powder is formed by these dried flower heads which contain pyrethrum, and this powder is extracted with organic solvents, and the extraction process is carried with the help of organic solvents such as diethyl ether, methanol, ethanol, tetrahydrofuran, etc. The volatile, generally volatile organic solvents are used so as it is easy to remove those solvents. The extract is concentrated by removing solvents by distillation, and the finally obtained dark green colored extract which contain pyrethrum, it has all insecticidal properties. So the process is the flower heads are dried, then dried, then they are crushed, their powder is made. This powder is extracted with organic solvent. Extraction is the process by which the organic content is dissolved in the organic solvent, and then organic solvent is evaporated with the help of distillation or a rotary evaporator process, and we get the absolute that organic compound that may be in liquid state or in solid state. And then that concentrated dark green colored extract after distillation or after removal of the organic solvents, we get it contain pyrethrum, and it has all insecticidal properties. This is the process how the pyrethroids are extracted or obtained naturally. Then the structure of pyrethroid, general structure of pyrethroid is like this. It is it contains this olefinic double bond as well as this three-membered ring, one ester group or ester functionality RCOO, this R, and we can replace all the this R and R dash by different groups and we will get different compounds. So if you see the general structure, then we come to know that if suppose this is one group, suppose this is R, and suppose this one is R dash, then the structure becomes R C double bond O O R dash. That means it is ester. So RCOR is nothing but it is ester. And so that only all the active ingredients of pyrethrum are esters. This statement is because of this. The general structure is shown here. And the four major ingredients of pyrethrum are pyrethrin 1, pyrethrin 2, cynerin 1 and cynerin 2. So these are the four major ingredients of pyrethroids. The four major ingredients. So how these four major ingredients, what is their structure? So the structure is the pyrethrin 1 is formed when we replace this R by CH3 and this R dash by this pentadienyl group. Then we will get pyrethrin 1. If the R dash remains same pentadienyl group and this R is COOCH3, then it will become pyrethrin 2nd. Similarly, cynerin 1 and cynerin 2 are the groups by which we can replace R and R dash by CH3 and COOCH3. Along with CH3 there is this group and only R value is changed when we compare the structure of cynerin 1 and cynerin 2. So pyrethrin 1 and 2 are the esters of ketonic alcohol, pyrethroline and chrysanthemic acid and pyretric acid respectively. Then here you see the structure that R in this structure, let us see in this structure when R is replaced by CH3, it is known as chrysanthemic acid because this group is this group is acidic group COOH, and when this R is replaced by CH3, then it is known as chrysanthemic acid. When this R is replaced by COOCH3 group, then it is known as pyretric acid. Okay, chrysanthemic acid and pyretric acid, these are the two acids by the replacement of methyl group and the COOCH3. When R dash, this R dash, see in this structure, now see when this R dash is replaced by this butynyl group, then it is known as cynerolone. Cynerolone because it is ketone. Cynerolone. And when this R dash is replaced by pentadienyl group, 1, 2, 3, 4, 5. Pentadienyl. This group, then it is known as pyrethrolone. So these are the nomenclature by replacement of respective groups. So we can say cynerin 1 and cynerin 2 are the esters of ketonic alcohol, cynerolone and chrysanthemic acid and pyretric acid respectively. The general term pyrethrin also include cynerins. That means pyrethrins does not only include pyrethrum, or they are also contain cynerins. So this is about pyrethroids, natural as well as synthetic. Thank you very much.